Hello class. Today we're going to be talking about scatter plots. So scatter plots exist because oftentimes when we're dealing with data, instead of using a line's not going to accurately reflect the information that we have. So let's take a look at an example. Let's say that I have data that correspond to around these points. Now, as you can see, there's no one line that's going to fit through all of those points. And so I have to create what's called a line of best fit to model what that line should look like. And so my line of best fit for this line is probably going to look something like that. And so I can use my line of best fit to make predictions about the data. In class today, we'll talk about how to find the line of best fit using the calculator. Right. So, for example, let's say that our line of best fit is given by y equal 2x plus 8. And we want to find the expected value for x at x equal, let's say 4. To find this, all we do is we plug in or substitute x equal 4 for x. So we're going to say y is equal to 2 times 4 plus 8. 2 times 4 is going to be 8 plus 8 is going to equal 16. So we get y is equal to 16. So the expected value at x equal 4 for this line is going to be 16. So we just got that the expected value is 16. What if, when we recorded it at x equal 4, we had an actual value of 14? And this is going to be fine, because as we know, as we said, our scatter plots are meant to model data. They don't necessarily have to have the data exactly. But if our expected value is at 16 and our actual value is at 14, we can calculate the residual. And the residual is the difference between what we expect and what we have. I'll write the rest on the next bit. And what we have. So as we said, our actual value is 14, and our expected value was 16. So the residual is going to be the difference between these two numbers. So it's going to be 14 minus 16, which is going to be negative 2. So my residual for this is negative 2. In order to find the residual, you have to first have the actual value, and then from the actual value, you need to subtract your expected value. So now let's look at an example, and I'll let you guys attempt this one. So let's say that you're given that the line of best fit for a scatter plot is y equal 4x minus 10. I want you to find the expected value at x equal, say, 7. Go ahead and take about 20 seconds to figure this out. Also find the residual. So find expected value and residual. Take about 20 seconds to get that done. If you need more time, feel free to pause the video. Alright, so to find our expected value, we're going to do y equal 4 times 7 minus 10. 4 times 7 is 28, minus 10 is going to be 18. Oh, you can't find the residual because I didn't give you an actual value. Let's say the actual value is 21. So if the actual value is 21, our residual is going to be 21 minus 18, our actual minus our expected, which is going to equal 3. So what we're doing when we find our expected value is, given a scatter plot, we're actually kind of looking at where the data is going to fall. So let's say that this is 1, 2, 3, 4, 5. 2, 3, 4, 5. So based on this, we want to see what we expect our data to be at 6. So we're going to say our line of best fit is around here. And so when we hit 6, we're going to be at approximately 6 on our y-axis. So we're expecting our value to be 6. Now, we could also show our actual value by having a point on this graph. So if our point was at 3, so actual is 3, then our residual is found by 3 minus 6, which is a negative 3. So that's going to pretty much finish up our notes on scatter plots. Tomorrow in class we're going to talk about how we can use our calculators in order to find our line of best fit. And then we'll use that to kind of look at how to find our expected value and how to find residuals. Thank you.